For this question, we want to determine the real solutions to the system of nonlinear equations. Our system has the equation y equals x squared minus 2x minus 6 and y equals negative x squared minus 10x minus 12. So before I start solving, I notice that the first equation is a quadratic, which has the graph of a parabola, and the second equation is also a quadratic, which has the graph of a parabola. So if I draw two parabolas, maybe we could draw them this way, you can see that there would be two intersection points and possibility of two solutions. You could also have the two parabolas maybe touching in a single point like this. And that would mean there would be one intersection point and one solution. And you could also have the two parabolas missing each other completely, maybe like this. So we could have no solutions. So for this example, we have the potential of two solutions, or one solution, or no solution. As I look at this example, I'm trying to decide whether I'm going to attempt substitution or elimination, and I think the two are equally as easy. I'm noticing that both equations already have a variable solved for, y. We have y equals, which is the first step in the substitution method. In addition to that, I can see that the variables, the like terms of y are lined up, the equal signs are lined up. We have like terms of x squared lined up, like terms of x lined up, and our constants lined up. So this also lends itself very well to doing the elimination method. If you choose to do the elimination method, y is the variable that I would try to eliminate, because you have two different x terms, an x squared term and an x term, and it is really hard to eliminate both of them at the same time. However, you only have one y term, so you can eliminate that y. But I'm going to use the substitution method on this example. We already have y solved for, and we'll substitute it into the other equation. And when I make that substitution, I'll have the equation x squared minus 2x minus 6 equals negative x squared minus 10x minus 12. This gives me a quadratic equation, and I want to move all the terms to the same side. So I'm going to add x squared on both sides, giving me 2x squared on the left. I'm going to add 10x on both sides, giving me plus 8x on the left. And I'm going to add 12 on both sides, giving me a plus 6 on the left. All the terms on the right cancel out. I have the equation 2x squared plus 8x plus 6 equals 0. It's a quadratic equation, and I'll try to solve this by factoring. All of these are even numbers, so I'm going to start by factoring out the greatest common factor of 2. And that leaves me with x squared plus 4x plus 3. And then I'll continue to factor that trinomial that's remaining. X times x is x squared. 3 times 1 is 3, and positive 3 and positive 1 will add up to be the middle of 4. We can set each one of those factors equal to 0 to get solutions of x equals negative 3 and x equals positive 1. So I might have an ordered pair where x is negative 3 and an ordered pair where x is 1 being the solutions to the system. I have the x coordinates, and I'll try to find the y coordinates. I'll use that first equation of y equals x squared minus 2x minus 6. If x is equal to negative 3, then y is negative 3 squared minus 2 times negative 3 minus 6. That's 9 plus 6 minus 6, and we get 9. So one of our solutions is negative 3, 9. Let's do the same thing with the other one. If x is equal to positive 1, it looks like I made a mistake there. It should be negative 1. If I solve x plus 1 equals 0, that's negative 1. So x equals negative 1. Then y is equal to negative 1 squared minus 2 times negative 1 minus 6. That's 1 plus 2 minus 6. 3 minus 6 is negative 3. So the other solution would be negative 1, negative 3. We've got our two solutions to the system of nonlinear equations being negative 3, 9 and negative 1, negative 3. On this question, we want to solve the logarithmic equation. I have this equation, log base 4 of 5x minus 6 equals 3. And I want to solve this equation. There are two main methods that we typically solve log equations with. And one of them is called the property of equality. And it follows the pattern something like this. Log base b of a equals log base b of c. So you have to have the log with the same base on both sides, and then you're allowed to simplify by saying what's inside the log on the left is equal what's inside the log on the right. So that's one of the techniques that we typically use to solve logarithmic equations. We can't use that here because we don't have a log on the right-hand side of the equation. So let's see if the other method would be a good one to use. So the other method is to take your log equation and convert it to an exponential equation. So if you have something like y equals log base b of x, then you can rewrite this log equation with the base to the y power equals x. So it allows you to rewrite that equation in something that's more familiar. And with this method, you typically only have log on one side of the equation, which is what we have in this example. So this is the method we're going to choose to do for this example. So let's convert this log equation to an exponential. It has a base of 4, so the base of the exponent will be 4. The log always equals the exponent, so we'll have an exponent of 3. And this expression is going to equal the expression inside of the log. That's the pattern that you follow every time you convert the log to an exponential. Then let's work out what 4 to the third power is. 4 to the third power is 64. We'll solve this equation by getting x by itself. We're going to add 6 to both sides. That gives me 70 equals 5x. Then we'll divide both sides by 5 to get x equals 14. So 14 is my proposed solution, and the reason why I say it that way is because with log equations you should check your work every time, and what you're checking for is that the solution that you came up with is in the domain of your log. So our log is log base 4 of 5x minus 6. We want to substitute that value of 14 in for x. We have 5 times 14 minus 6. and that's going to be 70 minus 6. And what we're looking for is it to be a positive value. For the logarithms, the domain is only positive numbers. You can only take the log of a positive number. So because this value came out to be positive, we know that 14 is in the domain of this log expression. So our solution is x equals 14. Thank you for checking out my videos. Have a great day.